This is going to be part one of a two-part video where I explain how to graph the function y equals cosine of 2x minus pi. So in the first part, I just want to find the, and actually let me write out this instruction because you're going to see this probably in your homework. Find the initial and terminal x values corresponding, I'm going to have to abbreviate, I don't want to spend the whole video with you guys watching me write this, corresponding to one complete cycle of the graph. So let's just say one complete cycle. Okay, so you start by considering the graph of just y equals cosine of x. So you definitely want to have that basic graph in your head. So the standard cycle that we usually draw for y equals cosine of x starts at 0 and ends at 2 pi on the x-axis. Now the shape for cosine starts and ends at its maximum value of 1. In the middle, it reaches this minimum value of -1. Halfway between the max and the minimum, it has an x-intercept here. And halfway between the minimum and the maximum in the second half of the graph, it has another x-intercept. And so the basic shape of the graph is this one. Now in part 2 of the video, I'm going to go in more detail about actually plotting those points. But for now, I just would like it if you had this basic shape in your head, and you know that that corresponds to the interval from 0 to 2 pi on the x-axis. And then that's one complete cycle. It'll repeat that shape over and over and over, off to infinity. Okay, but we're considering the graph of y equals cosine of 2x minus pi. So we've got some extra stuff going on inside the function. And the word for what's inside the function, by the way, is the argument. So if one complete cycle for the graph of y equals cosine of x occurs as x goes from 0 to 2 pi, then one complete cycle for the graph of y equals 2x minus pi is going to occur as 2x minus pi ranges from 0 to 2 pi. So if we solve this inequality, if we work our way down until we have x by itself, then that will take care of any horizontal transformations. Any phase shift or change in the period will happen automatically as we solve this inequality. This way you don't actually have to memorize the formula for phase shift and calculate that in advance. You can actually just let the inequality take care of that for you. Okay, so I'm adding pi across all three parts of the inequality. And then the one thing I have left to do to get x by itself is divide by 2. Again, make sure you do that in all three parts. And so here are our initial and terminal x values corresponding to one complete cycle for y equals cosine of 2x minus pi. It's going to occur as x goes from pi over 2 to 3 pi over 2. Okay, and that answers the question that I wanted to answer in part 1. Let me just say, by the way, that if we had found, I should probably get a new page here, on oops, okay, phase shift and period. Lost my train of thought there for a second. Phase shift, when the equation is in this form, can be found as opposite. So actually it's negative pi, because of the negative pi I see here, over 2. So pi over 2 for the phase shift. And the period is calculated as 2 pi over the absolute value of b, which in this case is 2 pi over 2, which is equal to pi. Now note that with our cycle going from pi over 2, oops, less than or equal to x, less than or equal to 3 pi over 2, the period there, the length of that cycle is pi. Right? If you do 3 pi over 2 minus pi over 2, you get 2 pi over 2, which is equal to pi. And the shift, the phase shift, if cosine usually starts at 0, but now we're moving it over so the cycle starts at pi over 2, then yeah, the phase shift did turn out to be pi over 2. And now I'll actually graph this function in part 2 of the video.